Good morning. Today we're going to talk about binomial probability distributions, and let me motivate the concept of binomial probability distributions with an example. Let's say find the probability of 5 boys in 10 births. Now, as we'll see, this is not quite so easy to figure out. Basically, we're looking for the probability of a certain amount of what we call successes in a certain amount of trials. So we've got 10 trials here, and we're looking for 5 boys, and I'm going to call what we're looking for the number of successes. Alright, so we're looking for the probability here of 5 successes, and the labeling of success is somewhat arbitrary in 10 trials. As we saw, listing out the sample space for this many trials is very cumbersome. The binomial probability distribution formula gives us a quick and easy way to calculate these what we call binomial probabilities. Alright, so in general, in this section we're looking for the probability of X, what we call successes, in a certain number of trials. Alright, we've got to get some notation down before we define and start practicing a formula. Let's talk about, in general, binomial probability distributions. Well, as we know, it's a certain type of probability distribution, and the bi and binomial is really referring to the 2 outcomes possible per trial, typically a success or a failure. There's 4 criteria that define a binomial probability distribution. Number 1 is that you have a fixed number of trials, either births of children, flips of a coin, answer questions in a multiple choice exam. All those referred to our fixed number of trials in any binomial experiment. The trials are all independent. That means the outcome of any one trial does not affect the probability of any particular outcome in any other trial. There are 2 outcomes per trial, denoted as success or failure, and typically the context of the problem lets you know which to label a success or which to label a failure. And the probability of a success, or of course then a failure, is constant across trials. If you've satisfied all 4 of these criteria in your statistical experiment, then you've got a binomial probability distribution. Alright, let's get some notation down. And our goal here is to establish what we call a binomial probability formula. The probability of success in any one trial we will denote as a lowercase p. Well, then there's only 2 outcomes per trial, so then the probability of failure in any one trial will of course be 1 minus p, and the notation for that has evolved is q. So q is probability of failure in any one trial. Our number of trials in our binomial experiment we will symbolize with a lowercase n, and the number of successes that you're looking for in your particular binomial experiment we will denote with x. So P of x, or probability of x, is really the goal here in these binomial distribution problems. It's the probability of x successes in n trials. Alright, I'm going to write down what we now call the binomial probability formula. Gives us a quick, relatively quick way to grind out probabilities in this type of scenario. Well, if we embrace those symbols that just scrolled up, we can write our probability in this fashion. Basically, the binomial probability involves three factors. We've got n combine x, or n choose x. Now don't panic, this function, I call it n choose x, some books call it n combine x. It's built into our TI-83, 84 calculators, and I'll show you how to get that operator in a moment. Times p to the x power, well, that's just your probability of success in any one trial raised to the x power, times q to the n minus x would be the probability of a failure in any one trial raised to the n minus x power. Alright, n choose x is under the math menu in the calculator, TI-83 or 84 calculator. For example, if I wanted 5 choose 4, I would go to my home screen and, well, first I'd clear everything, enter in a 5, then type or press the math button. Under the math button there is a submenu. We'll want to scroll and select PRB for probability, hit enter, and under the probability submenu you'll see this command NCR. So highlight it, scroll down, highlight it, and select it, and then if we enter in a 4, you'll see the 5 choose 4 command come up on your home screen. So a few button pushes, 5, then math, then Prob, then NCR, then 4, gets you this value, 5 combine 4, or 5 choose 4. Now if I go to my calculator, hang on a minute, I'm going to dig it out of my bag here, I'll grind it out. 5 math Prob for probability, NCR, call that up to my home screen, then hit 4, and I get 5. So 5 choose 4 equals the number 5. Right, we'll talk more about the actual values in a minute. I just wanted to give you some practice on finding that n choose x command. Okay? Alright, I'm going to now work out an example using this formula for particular values of n and p and x. Let me get a fresh screen here. Alright. I'm going to assume the probability of a boy in any birth is 0.7. Of course, that's not what we would experience in real life, but for the purposes of clarity in this example, we're going to make that assumption. And I'm going to ask you to find the probability of 3 boys in 5 births. Kind of a simply stated question, but not so simple to grind out. A lot of students would say 3 over 5 is 0.6, but that's not going to cut it here. We're going to need the binomial probability formula. All right, we've got a fixed number of trials here. We've got 5 trials. The probability of success in any trial is 0.7. Now you're calling a boy a success here, so I'm going to say the probability then of success is 0.7. Q is always 1 minus P because there's only 2 outcomes per trial, and my X value, the actual number of successes I'm looking for, is 3. So according to our binomial probability formula, the probability of 3 successes, probability of 3 successes in 5 trials. I don't know what's going on here. Hang on a minute. I'm having trouble with this pen again. It's going to be 5, choose 3, substituting n, 5 for n and 3 for x, times p to the x power times q to the n minus x power. Alright, now I could punch this out pretty easily now. Remember, 5 choose 3 is under the math menu, so I'm going to type 5 math, press your math button, select, highlight and select the probability sub-option, scroll down and select NCR, and then enter 3. So on your calculator, if you execute those button pushes, I should see 5 choose 3 times, on your calculator, your times button will come up as an asterisk, times 0.7 raised to the 3 power times 0.3 raised to the 5 minus 3 is going to be second power. So I'm going to write this as 0.3 caret 2, because 5 minus 3 will become a 2 at that exponent level. Okay? Alright, so if I punch this out, just enter in these keystrokes, I get 0.3087. .3087. Okay, so that's the probability of 3 boys in 5 births when the probability of boy is 0.7 in any birth. Okay. All right, there is another way, another somewhat simpler way. What I'm getting at is the binomial probability formula is already pre-programmed into the TI 83 or 84 calculator. And I'll show you how to get there in a minute. Alright, keep in mind that the answer to the example that I gave was 0.3087, and I'm going to show you how to access that binomial probability formula on our calculator. The operator we're looking for in our calculator is called Binomial PDF. Right? It's under the distribution menu, and I'll show you how to get there in a minute. The syntax for this command is Binomial PDF. By the way, PDF stands for probability density function. The syntax for that operator is Binomial PDF NPX. There are instructions in the textbook. There's also instructions in the guidebook manual that comes with the calculator, but I'm going to show you how to get there right now a little more informally. Well, you're going to have to access this distribution menu. It's at the second level above the VARs button, So press your second level button in your calculator, the gold button, and then the VARs button to access that distribution command. And then we'll want to scroll from that distribution menu to highlight this binomial PDF operator. Hit enter, and that will call up that command into your home screen on your calculator. Then type in your choice of N and P and X in that order, and then hit enter to compute your actual probability. Alright, so for the above example, we want to hit second level, distribution, scroll and highlight and enter for binomial PDF operator. We're going to want to enter in, well, we had 5 births. The probability of boy in any one birth is 0.7, and we were looking for the probability of, alright, we will enter in 3 for our desired number of successes. And if I punch this out, enter this command, this is the command you should have entered into your home screen, and if I punch it out, I get 0.3087, the same value I got grinding it out by hand. Alright, so we're going to be using this command quite a bit, binomial PDF, and it does save us quite a bit of labor regarding pencil and paper calculations. Again, for more info on binomial PDF command, there's a couple of places we can turn. We can see the using technology gray box in our textbook. We're familiar with these using technology boxes. We've seen them before. For this particular command, see the instructions on page 224. So you've got some written and more formal instructions regarding this binomial PDF operator right at your fingertips in the textbook. Or we could also see the TI 83 or 84 guidebook for much more formal and detailed instructions regarding this command. Okay? Alright, I've got 3 or 4 examples of illustrating this binomial probability formula, and again we're going to use the calculator in grinding all these out. This is number 29. I believe it's in your homework list on page 226. So please turn there and familiarize yourself with the problem. I will too. Let's see, 29. Alright, I'll read the problem here. Brand recognition. The brand name of Mrs. Fields cookies has a 90% recognition rate based on data. If Mrs. Fields herself wants to verify that rate by beginning with a small sample of 10 randomly selected consumers, find the probability that exactly 9 of the 10 consumers recognize her brand name. Alright, so we've clearly got a binomial probability type problem. We're asking 10 people, do you recognize Mrs. Fields? and we want the probability that 9 of those 10 will recognize Mrs. Fields. Alright, so our number of trials is 10. We're asking 10 people this question. We're looking for the probability that 9 of 10 recognize her name, and the recognition rate is given to us in the problem as 90% or 0.9. So the probability that any one person would recognize her name is 0.9. And the desired number of successes we're looking for, well, we're looking for 9 successes in 10 trials here. So we want the probability of 9 successes in 10 trials, where a success is recognizing Mrs. Fields' name. Alright, so the probability of 9 successes in this case, well, if you want to grind it out by hand using the binomial probability formula, this is how I would grind it out. It would be 10 choose 9, or 10 combine 9, times 0.9 to the 9th power times 0.1 to the 1st power. Of course, if you're like me, you'll probably want to use the Binomial PDF command on our calculator. Alright, so we should be familiar on how to call up this command into our home screen through the distribution menu. Alright, so enter in Binomial PDF with N and P and X written in that order, and punch it out, and I get a 0.387. Okay. Alright. Let's try another example here. I'm going to look at number 39 in our homework list. And this is on page 228. I think I can squeeze this in. I'm going to read the problem. In a survey of 320 college graduates, 36% reported that they stayed on their first full-time job less than 1 year. And I'm going to just do part A here, 39A. Let me write that down. If 15 of those subjects are randomly selected without replacement for a follow-up survey, find the probability that 5 stayed on their first full-time job less than 1 year. Alright, I'm going to assume we're doing this with replacement because 15 is certainly not more than 5% of 320 college graduates, so I can invoke that rule. Alright, so basically I'm asking 15 people, 15 of these subjects, did you stay on your first full-time job less than 1 year? Alright, so my number of trials is 15. Overall, we know that 36% or 0.36 of people stay on their first full-time job less than 1 year, and we are told to look for the probability that 5 of them stayed on their first full-time job for less than 1 year. Alright, so now it's a simple plug and chug into the binomial PDF operator. So go to your distribution menu, highlight and select Binomial PDF, call that command into your home screen, and enter in your values of N and P and X. Oops, X, I forgot to write down X. We're looking for 5 here. As needed. Alright, if I punch that out, I get 0.209. This is the probability of 5 successes in 15 trials in this particular problem. Let me write that down. Probability of 5 successes, where a success means not staying on your job or staying on your first full-time job less than 1 year in 15 trials. Okay? That's number 39, part A. Alright, let me get a fresh screen. I want to look at number 42. Also in your homework list, talks about overbooking flights. This is number 42 on page 228. Alright, let me read the problem. Overbooking flights. When someone buys a ticket for an airline flight, there is a 0.0995 probability that the person will not show up. An agent for Air America wants to book 24 persons on an airplane that can seat only 22. If 24 persons are booked, find the probability that not enough seats will be available. Alright, so there are 24 tickets sold, but there's only 22 seats on this airplane. So the book is asking us, find the probability that not enough seats will be available. Well, basically we're asking 24 people, did you show up? And if the number of people that show up exceeds 22, there will not be enough seats available. So let me write this out. The probability of not enough seats, well, that's equivalent to the probability that either 23 people show up or 24 people show up. All right? Equals the probability, let me write it this way. The probability of not enough seats is the probability that 23 or 24 show up for the flight. Okay? Alright, well, we've sold 24 tickets, so there's 24 people that have a chance of showing up or not. The probability that any one person will show up, well, let's see, we have to think about this a little bit. The book tells us there is a 0.0995 that a person will not show up. Well, that means there's a 0.9005 probability that any one person will show up. Okay? Or I'm calling showing up a success. Alright, so X is then going to be, well, we're worried about 23 or 24. So basically we have to grind out this binomial probability command for two different values of X. Right? I'll write it out like this. The probability of not enough seats, that's the same as the probability that X is 23 or X is 24. In other words, that either 23 people actually do show up or 24 people actually do show up. Alright, because this is an OR probability and because these are disjoint events, they both can't happen simultaneously, I can just add up the probability of the 23 case and the 24 case, and that will satisfy. Now, of course, I'm going to use my binomial PDF operator, and let me write it out like this. Binomial PDF, well, for the 23 case, I'm going to have a 24 trials, a probability of success of showing up of 0.9005, and 23 successes in those 24 trials. And to that, I'm going to add binomial PDF evaluated with 24 trials, 0.9005 with 24 successes. Alright, so I need to evaluate those two formula expressions at the indicated values, and let's see, I'm going to keep as much decimal accuracy as I can stand here. The top command gives me 0.214368. I'll round off to 6 decimal places, which should be plenty. And the probability of 24 successes in 24 trials will then be 0.080837. And if I add these up, and I'm going to round off to 2 decimal places, I get a probability of 0.295. So with this given information, the probability of not enough seats is then 0.295 in this case. Okay. One more I want to talk about. Number 31 in our text. I don't want to ruin the surprise of all the homework problems here. But 31 involves an at least type situation, and I want to be sure to talk about at least one of these at least type problems. 31 talks about eye color. This is on page 227. Let me read the problem. In the United States, 40% of the population have brown eyes. So let me write that down. 40% have brown eyes. 40% brown eyes. I just plugged in my computer, forgive me. Battery was running down. Alright, 40% of all people have brown eyes in the United States, according to someone from Indiana University. If 14 people are randomly selected, find the probability that at least 12 of them have brown eyes. Alright, so we're asking 14 people, do you have brown eyes? So I've got 14 trials. The probability, we're going to be calling brown eyes a success here. Alright, so the probability of brown eyes in any one person is then 0.4. Now we want the probability that at least 12 of them have brown eyes. Well, what does at least 12 mean here? That means your number of successes is going to be 12 or greater. That means X is 12 or 13 or 14. So you guessed it, you have to grind out your binomial PDF formula for 3 different values of X and add them up. Okay? So let me go and make the substitution. The probability that X is greater than or equal to 12 in this scenario, well, I'll take the 12 case. Well, remember we've got 14 people. The probability of success in any one trial is 0.4, and I'll cite 12 successes plus the probability of 13 successes in those 14 trials plus the probability of 14 successes in those 4 trials. Now what I like to do is I can enter all this syntax in one window of code on my calculator and let the calculator do the work. If you want to evaluate each of these 3 values independently and then add them up, that's fine, but I like to spend as little time button pushing as possible. I would like to enter these in as one window of code. It's going to take more than one line on your calculator, and if I add these up, I get 0.000609. Depending on the settings of your calculator, it may illustrate this in scientific notation. Okay, the calculator, the TI syntax for this value in scientific notation would be 6.09 e minus 4. That's the equivalent to 6.09 times 10 to the minus 4th power in scientific notation. Okay? Alright, so we're reaching the 35-minute point. We defined the binomial probability distribution formula, and we've worked out at least 4 examples of how to solve these type of problems. I think that's enough of a foundation for you to tackle the homework problems, and we will meet in our next face-to-face class on Wednesday in preparation for our test Friday. Alright, that's it for today.